Welcome everyone, so great to see you all in person and to see so many people. This is fantastic. A small worry this afternoon of going, is anyone going to come? Is anyone going to come? So it's really great to see you all here.
Rent a crowd.
We have had a few events already this year, so I'm just going to quickly mention what some of those were, which have all been online, or we had one in person already. So we had in March, we had our first Cafe of the Year, which is a deadly dance when black holes and neutron stars collide, with Dr. Alois de Vance. And then in April, we had Ancient Futures, late 18th and early 19th century Tongan arts and their legacies, with Phyllis Herder and Dagmar Waikalaki Dyke. And then we had, at the start of this month, we had Who Were the Other Cheesemans, with Marguerite Durling in the museum library. So we had a sort of a slow start to the year with being online, but we do have a range of more activities that are going to be happening over the next few months, organised by, of course, our body, the Auckland Museum Institute, which is also the Auckland branch of the Royal Society Te Aparangi. So of course, we all know what we're here for today, which is Squidology 102. Well, most of us passed Squidology 101 on the first attempt back in 2019, and I think it was a whole 5 minutes after the cafe ended when people said, right, so when are we doing the next one? And it's taken me till this long to hold the cat down long enough to agree to it. But so next month we have Dr. Dan Hikaroa from University of Auckland, who's going to be talking to us about Matariki, Matamatanga and Mataronga Māori, just in time for our first ever Matariki holiday. So that's going to be fantastic. And then following that, at the start of July, is Cityside, the science festival that is happening at the University of Auckland on the Saturday. And then we have the following week, the inaugural Auckland Museum Institute Humanities Lecture, where Dr. Vincent O'Malley will be talking about the Great War for New Zealand and the making of Auckland. In July, at the end of July, our cafe then is catchment modelling for water quality and what they can and can't tell us, with Dr. Annette Semadini Davis from NIWA. At the moment, we don't have a speaker for August. Our speaker has had to pull up for medical reasons. So if there's anyone who's dying to give a cafe, please get in touch with me. And then in September, we have the annual Lucy Cranwell lecture, which will be Dr. Colin Merck from Landcare talking to us about urban ecology. Also in September is the annual Hochstetter lecture, which is Dr. David Pryor from the University of Otago talking about the shear zones that hold back the ice sheets. Then we have, also in September, Professor Kathy Campbell, who's a fellow of the Royal Society from the University of Auckland, talking to us about the search for extraterrestrial life in the solar system. And then finishing out the year, we have Pete Brooks from Auckland Council talking to us about environmental engineering. So we have a very full year. A lot of those things will be in person. We've got a few more things that are in the works but aren't quite ready to be shared yet. So you know that there's a lot of events coming up. If you aren't a member of the Auckland Museum Institute and you want to be included in these events and free entry, go to the Auckland Museum website, click on Join Now, and the details are all there. Right, I think I've filled in enough time so that all the latecomers can slip in and sit at the back. So without further ado, we're going to introduce our favourite squidologist, who needs no real introduction, Associate Professor Kat Bolstad. Shall we give her a round of applause?
Kia hora te marino, kia whakapapa pounamu te moana. He huarahi mā tātou I te rangi nei. Aroha atu, aroha mai. Tātou ia tātou katoa huie, tai ki e. Ko te whare wananga aronui o Tamaki Makaurau te wananga. Ko kai ako aho I te kura putaio. Ki te ako aho I ngā ngū, rawa ko ngā whiki. Ko Kat Bolstad, tako ingoa. Thank you very much for having me this evening, having me back this evening, and coming along mostly to see Vera, I assume. I mean, those of you who were here last time already met Vera, but I figured she probably needed to make an appearance again. And she's a very good prop for explaining the ins and outs of cephalopod anatomy. So I'm from Auckland University of Technology. I run the AUT Squid Squad, most of the current members of which are over in the corner here, as well as a visiting scientist from Chile, that's David. So actually we could crowdsource this talk and I could make different people come up and give parts of this and introduce you to cephalopod anatomy, and I could just sit down. So I've got a few different things I thought I'd talk to you about this evening. If you've tried out your hand at the squiz that's sitting on the tables there, there's no marking on that, but I'll try to hit sort of the major points of that tangentially through talking about other things across the evening. And I realized how dependent on screen visuals I've become when I was thinking about the animals I wanted to talk about, and I was going to point to, nope. So I have some visuals on the table for you so you can see a little bit about what I'm talking about with some of these more unusual deep sea cephalopods. So I guess really quick review of our Squidology 101 course. Squids are cephalopods. Cephalopods are a group of squishy animals that have a body that's either long and skinny like a squid or, thank you Hank, prop number 1. Squishy like a weird nose at the back, right? This is an octopus. They have arms, they have tentacles. I'll get into that a little bit more in a minute. But this group contains octopuses, squids, cuttlefishes, nautilus, little thing called the vampire squid, some dumpling squids. Many of the things called squid are not actually squids, confusingly. I specialize specifically in things that are actually squids, like this one. And we have quite a few species in the waters around Aotearoa, New Zealand, as it turns out. And across sort of 18 years of working here, it turns out we have at least 40 more species than we thought we had previously, because as soon as somebody looks closely at them, it turns out that some of the names we were giving things here are not the correct names for those things. And sometimes they already have a name and it's a different name, and sometimes it doesn't have a name yet in the Western Linnaean system. And in that case, we try to give those things names so that we can properly study their ecology and make sure that we're all talking about the same thing. So really quickly, before I get into some of the weirdos, so that you know the different bits that I'm talking about, I'll walk you through what makes a squid, right? So this is Vera. Vera was handcrafted for me by one of the members of our lab in 5 days, and was a surprise for me when I walked into my office and she was deployed across my desk. Vera is a full-size female mature giant squid. So this is the maximum size that we know giant squid to grow to. It's always possible they could get a bit bigger, but this is the biggest that we've ever actually seen. She's lying upside down at the moment, and I'll tell you why in a moment, so you can tell because the funnel is on the top. So I mentioned this is the mantle, this is the body with the little fins at the end. Fins are very small in a giant squid. I have another small one here I brought with me. And the body is the part that contains all of the internal organs and is a tube, so if you cut it like this, that's where you get squid rings from. So calamari is the mantle of the squid cut crosswise. Incidentally, giant squids are full of ammonium, so not good for tractor-sized calamari unless you like the taste of bleach. The squid's head has got all of the same stuff in it that your head has, except for a skull, of course. 2 eyes, the brain, more about that in a little while. The mouth is in here among the arms. I could be extremely rude, reach in here and take out Vera's mouth. Here's the beak. This is proper size for a giant squid beak as well. So the beak is the mouth parts. It's situated in the middle of all the arms. And this large tangle at this end then is the arms. There are 8 of them. And 2 very long tentacles, one of which is sitting over there at the Squid Squad table, and one of which is folded back on itself 3 times here to make the full 13-meter length of a mature female giant squid. And males are a little bit smaller than that. And the reason that Vera is lying upside down is because she's also anatomically correct. So I'm not going to do a full squid anatomy thing here, but I'll leave her open and you can come up and have a look later. Yeah, thanks for that. So Okay, so we have a giant squid. We have a general overview of the body parts of stuff. I talked about giant squid quite a lot last time, and I'm happy to do that again. But you will have noticed that mostly we wanted to talk about some of the weirder things that live in the deep sea. And are there things weirder than a giant squid? Yes. Yes, there are. So I thought we would do maybe a little choose your own adventure style thing here. I'm going to give you the option of whether you'd like to hear first about a squid that has claws like a cat's claws all the way down all the arms, or the one that has the largest light organs in the animal kingdom. So we'll do a quick show of hands. How many people want to hear about the cat claws? Okay, how many people want to hear about the light organs? Oh, I think the light organs takes it. Okay, fear not, cat claw people. All will be revealed in due course. Okay, so if you answered true that a squid has the largest light organs in the animal kingdom on your squiz, you are correct. So as far as we know, the largest light organs, or photophores, are possessed by a squid called Taningia. And I mentioned that we have a bunch of things here that were given a specific name that turned out to have different names. So a fairly recent graduate from PhD graduate from AUT, Jesse Kelly, for his PhD, revised the whole group of squid that contains Taningia. And it turns out that instead of one species worldwide, which is what we thought we had forever, there are at least 6. And in New Zealand, we have 2 of them. And in April last year, a fisherman caught one, quite a large one, and we did a dissection on site at AUT and posted lots of photos of that on Twitter. And I meant to mention as well that if you're not on the Café Scientifique mailing list, I will send out a bunch of links to videos about the animals I'm talking about tonight after this as well. So if you want to be on that mailing list and you're not there yet, I can send videos so you can see these animals swimming around and doing cool stuff. So, right, so Taningia, which was named after a Danish scientist named Toning, so it should actually be Taningia, but that's not how things always work. Taningia gets up to about 2 to 2.5 meters long, and is characterized in a family that's characterized by the lack of tentacles. So this brings us quickly to the questions 1 and 2. Do octopuses have tentacles? Hands up if you say yes. Okay. Do squids have tentacles? Hands up if you say yes. Okay. Squids do have tentacles, as I revealed by Vera's tentacles over here. Octopuses do not. Although it is really fun to say tentacles, and lots of people go ahead and say tentacles, that's fine. I'll show you on Hank here. Hank has, well, he doesn't even have the right number of arms, unfortunately, which is why he looks so grumpy. Hank should have 8 arms. He's got 7. So octopuses only have arms. And the difference between arms and tentacles is the arms have suckers all the way down them. And the tentacles normally are longer and only have suckers right at the very end, concentrated in a little pad at the end called a club, which may also have hooks instead. And the arm suckers may be hooks instead as well, as I alluded to earlier. All right, so Taningia is a very large squid, grows up to maybe over 1 meter of mantle length. So Vera's here is about 2.5 meters. Taningia, if we had a full-size Taningia on the table, would take up about the length of Vera's mantle. So it's a pretty hefty squid, and instead of these weeny little giant squid fins, Taningia would have fins that were across the entire body. So very large fins, and in fact, the first 2 images, I think, on your page of images, which is A and B, are of Taningia. So there's a Taningia swimming in the water there, and then there's a close-up of some cat-like claws. So surprise, both people won the Pick Your Own Path adventure because Taningia is also the squid that has the cat-like claws up and down all the arms. So in the first image there, in image A, you can see the light organs flashing. So on 2 of those 8 arms, at the tips, there are light organs that are about the size of a walnut or maybe a very small lemon. They're bright yellow, and they sit behind dark flaps of skin that are a bit like eyelids so that the squid can open and close them and flash them in the darkness. And one of the video links I'm going to send out is of a Taningia coming through the submersible frame and signaling to try to figure out what it's looking at and then stopping signaling and going away. And in fact, when scientists have deployed light lures where there are 2 of them, sometimes they get a Taningia that comes up and flashes trying to make contact, perhaps, and then gives up and heads off. So you can actually get a signal response from them with a pair of lights in the distance. What exactly those light organs are used for remains as mysterious as many aspects of things in the deep sea. Possible that highly likely that they are intraspecies signaling, so signaling to other members of the species. They're eaten quite a lot by sperm whales, so there's also a chance that there's some kind of defense, startle in the darkness, bright flash situation going on as a defense mechanism. We don't know for sure. What we do know is that they do have them, these large light organs. All Taningia have them, and they seem to be the largest light organs in the animal kingdom that we know of so far. They're pretty impressive. And then on those 8 arms, Taningia also has, instead of suckers, has hooks that run all the way down the length of those arms. And those hooks are like a cat's claws. And in fact, if you're handling them and you're not careful, they'll tear your gloves open. So they're extremely sharp. They seem to be able to move each hook individually as well. It sits within a fleshy sheath. So probably those hooks are helpful for handling fairly large prey. Although if you're familiar with cephalopods or were here last time, you might remember that this is the size of a squid's esophagus. So the very large prey, if they choose to handle large prey, still has to get cut down into very small pieces. That's particularly important because the esophagus runs directly through the middle of the donut-shaped brain. So if you don't chew your food properly, you're in big trouble if you're a squid. So some squid choose to just handle smaller prey then and chew it up into really tiny, unrecognizable pieces, as some of my students over here could tell you, because they're doing gut content projects where they try to figure out what the little tiny pieces are in the squid stomach. So some squids do still handle large prey, but then they still have to cut it into very small pieces so that it can go through this tiny tube, through the brain, all the way to the other end of the body. Digestion happens down here, makes a U-turn, comes back out, and actually gets released out the intestine here, and then comes out, the waste comes out the funnel. And I'm going to go on a little, a slight detour here, because this is the part of the squid that hosts the digestive stuff. It's a bit of a complicated system, but this is what we would call the stomach cecum, right? So the squid have a muscular stomach, and they also have a pouch where most of the digestion happens. That's the stomach cecum, and as it happens, Vera has had some lunch today. Anyone want to guess? Pizza. Well, she hasn't been behaving very well. So this is my moment to quickly debunk the fact that giant squid do not pull sailors screaming from ships into the ocean. They live generally about 500 meters or deeper, and no healthy adult giant squid will ever be found at the surface. So although there are fantastic legends of the kraken and giant squids causing all kinds of havoc at the surface, which are really fun to think about and paint and create art based on, I can tell you that to the best of our knowledge, giant squid tend to eat smaller squid and fish about this size. And again, that's a fairly efficient way to get the smallish prey, which has to then make it all the way down the digestive tract to this end. So I have never found any remains like this properly inside a giant squid before. Admittedly, they don't usually have stomach contents, so we could be missing a big clue here. But for the moment, it's just a prop. Okay, so Taningia, I'll just mention as well about the tentacles. So one of the main differences between octopuses and squid is that squid have tentacles. This is true of cuttlefish as well. If you find an animal with tentacles and you know what tentacles look like, you can be guaranteed that that animal is not an octopus, even though there are squids that look fairly like octopuses. Unfortunately, if it's missing tentacles, you can't rule out the fact that it's a squid, because there are whole families of squid that lose the tentacles from an early age, and or those things tend to get ripped off due to rough handling, or sometimes when they're reaching maturity, the tentacles drop off as well. So that was a really quick rundown of Taningia, which has those nice large light organs. I don't have a page in front of me, but I see that we've got the light organs, and the specimen in the middle, B, is the one that we looked at AUT last year. That was one of the biggest Taningia, which was the original species that we looked at last year, and then C is those cat-like claws. Okay, so that's deep sea weirdo number 1 that you should definitely be aware of if you have an interest in cephalopods. Okay, the next one, I'm going to ask you another question. Do you want to hear about stealth lights, or do you want to hear about a squid that has one eye way bigger than the other? Both. Both? I was wondering how many times I could get away with this gag. Again, they're the same. So the next two images that we've got are of squids that have a variety of colorful common names. They are called strawberry squids, cockeyed squids, violet squids, or jewel squids. More scientifically, they're in the family Histioteuthidae. And if you look at those images, you will see that they've got lots of little dark dots on the underside. And that's on the underside of the mantle and of the head and of the arms. And you might be familiar with the fact that there's a common coloration pattern in marine animals where they're lighter underneath and darker above, right? They've got what's called counter shading. And that means that when animals looking below them look up, they see the white belly and the animal is camouflaged against the surface light. Looking down against a dark background, the animal is camouflaged from above. So a lot of deep sea animals that live in what's called the twilight zone, which is where there's a very small amount of light or light is functionally disappearing, have what's called counter illumination. So instead of, or in addition to being light colored underneath, they have lots and lots of light organs or photophores that are blue-green and that pretty much exactly match the color of the light that wells down from the surface, so that their silhouette is not visible. Because it doesn't do you any good to have a white belly if you make a dark shadow against the light, what little light there is coming down from the surface. So there are lots of different examples of this in different animal groups, as well as in cephalopods, but some of the most beautiful ones, I think, are these Histioteuthids or jewel squids. So they have these beautiful blue-green light organs underneath, but I mentioned also that they've got one eye larger than the other, and all the squids in the family have this. The left eye is up to 2 to 2.5 times larger than the right eye. So this brings us to the squiz question about symmetry. So do cephalopods have radial symmetry? You might think that they do because of the ring of arms. In fact, they all have bilateral symmetry, right? So they're symmetrical across a midline, except when they aren't. Except when they have one eye bigger than the other eye, which is until recently only known in this particular family, but we had a student just finish a project where we found a slight difference in eye size in a completely unrelated group of squids as well, which was pretty exciting. So what are they doing with the eyes that are two different sizes? Does anyone want to have a guess? What function might that have? You can see in image E, you can see the really large eye on your right side. It's a big green lens, and on the other side you can barely see the eye at all.
Different depths.
Different depths?
Different light penetration.
Okay, so the eyes might be specialized for light penetration or for seeing optimally at different depths the squid might go to. Yes, a lot of deep sea animals migrate up and down the water column, and so they do go through different light regimens or across those different depths or different times of day. That's a great guess. Any others? Any other thoughts? One is facing up and the other is facing down. It's like you've taken my class in deep sea biology or something, Lucas. Spoilers. Oh, next semester. You haven't taken it yet. Okay, now you're going to have to give this presentation next time. Yeah, that's right. So the one you can kind of see it in that image. One of them is looking up and is looking for animals above and is watching for those silhouettes and watching for predators that might approach from above. And one of them is looking down and watching for danger that might be approaching from beneath. And the super clever thing about this is you can see that that eye lens has kind of a green coloration. So that green coloration filters out some of the wavelengths of the other animal's counter illumination so that their perfectly matching color from the surface is out in the squid's vision. So the squid can see when its prey, which thinks that it's camouflaged from the surface, is matching the color from the surface because that eye screens out some of those artificial wavelengths that the animal is producing. So it has its own stealth running lights, and it also can see through the attempts at stealth running lights of its prey, which is pretty fantastic, I think. Okay, so that's another group where it turns out we have a lot of undescribed stuff. And in fact, Until recently, all 20 or so species in that family were thought to belong to just 2 major groupings, 2 genera. Heather, our squid crafter, is also a geneticist, and she is famous in our group for breaking up families. She's a homewrecker. She likes to look at squid families and say, oh, actually, that's not enough divisions. There are more species, and you have to group them differently. So she's about to split that family into 6 instead of 2. Thank you very much for that, Heather. We can relearn all of the names together now. Okay, so the other group of real deep sea weirdos I wanted to talk to you about is the ones that you can see on the back of that page or on the next page. So there are 2 squids that look kind of like light bulbs. One looks like a long, skinny light bulb, and the other one looks like, well, it looks like a piglet light bulb. And that is, in fact, a piglet squid. That is letters, what did I do? F and G. F and G. So this is a family of squids called the glass squids, and you can see why, or Cranchiidae is their Latin name. And this is one of the most diverse groups with the most species of all of the deep sea squid families. They're found in all the world's oceans. They live in the Antarctic, where they include the colossal squid, which does not look like a giant light bulb, so is a bit of a weird one for the family, but does definitely belong in that family. And what you see there is, in fact, what they look like when they're alive. So these are squids that have taken stealth to the next level by saying, well, I'm not going to hide all my internal structures. I'm just going to make them as small as possible and then pretend that the rest of my body isn't here. So you can see in the piglet squid that really there's only one thing inside the mantle that is not transparent, and that's that weird sort of caterpillar-looking thing that's in the middle. Now, in Vera, the digestive gland or the liver is this big, horrible colored, pillow-sized 20 liters of yuck if you ever get the chance to examine a giant squid. This thing here. So the Cranchiids, or the glass squids, have managed to reduce that as much as possible and flip it up on its end and put the ink sac underneath so that it's the tiniest possible silhouette from underneath. So they've made everything in their body transparent possible across millions of years of evolution. And the things that they can't, they've hidden by either minimizing the silhouette from beneath or hiding them with light organs. So the Cranchiids also have light organs on the underside of their eyes, because the eyes are the other thing that have not become transparent across evolution. So I can't remember if you can see it really that well. The eyes are extremely shiny, and then the underneath of the eyes is masked from above by some light organs as well. And we've got quite a few undescribed species of these guys in New Zealand waters as well. They're a particularly challenging group to work on because when they come up in trawl nets, which is how you tend to get specimens of deep sea stuff, the eyes tend to deflate, and the rest of the animal looks like a crumpled plastic bag. So images like this are actually extremely valuable to us for being able to see what these animals look like, both in life, but also just to get an idea of what they look like intact at all. And with increasing access to ROVs and different kinds of deep sea video footage, we actually are getting a much, much better idea of the lives and ecology of these animals than has been possible from the rather sorry-looking specimens of what was once a very beautiful animal and really doesn't look like much. We had someone in the group who was working on them, and we were always very happy to be like, it's Erin's problem. We've got one for you, and good luck with it. Yeah, so I think those are probably my top 3 picks for deep sea weirdos. There are many, many more. There are others who have hooks. There are others who have cool light organs. Of course, I have to give a little nod to the vampire squid, which is the other one I've given you a picture of in H. How many people voted yes for vampire squid is a good name? I mean, it kind of is, right? Like, vampire squid is a good name. On the other hand, this animal is a detritivore. So it eats marine snow, which, if you don't know, is like waste from higher levels of water that just drifts down. So it's actually the only known cephalopod that just eats rubbish that drifts down from other marine animals. And it's not a squid. So vampire squid is a great name, but it also isn't a great name for this animal. I mean, like, if you had the chance to call something a vampire squid and talk about the vampire squid, you would, but it's not the most accurate name for this little sort of football-sized, nearly vegan midwater cephalopod. But, you know, everybody loves the vampire squid, and they are really interesting to come across. They're actually more closely related to octopuses than they are to squid. And they have all kinds of interesting light organs as well. And one of their defenses is that they turn themselves inside out, sort of. They take all of the arms with a deep web between them and flip them back over the body like this. And they look like a balloon, and then they've got little finger-like things that stick out and look real thorny, but are in fact incredibly soft. And they do what's called the pineapple posture. I don't know how helpful that is, actually. I kind of think if something is hunting a vampire squid, it's not really that worried about the pineapple posture. But they do have one other super cool trick, which is that they have a couple. So they have two really big light organs at the end of the body, and they will light up those organs and make them, you know, quite bright. And also they have kind of eyelids over them that they'll have kind of out to maximum size. And then they will really quickly shrink the skin around them to make it look like they really quickly went really far away. And then they do like a little somersault. So it looks like they disappeared into the distance, but really they're right here. But, you know, they're still around, and they probably haven't changed really for tens of millions of years. So something about this appears to be successful, even if we think it's a little bit funny. Okay, what else did I forget to talk about that's on the squiz? See, I left it for myself as a prompt.
Aliens.
Oh, aliens. Oh, yes. Are cephalopods aliens? What do we think? Like, you know, they sequenced the octopus genome a while ago, and it was all over the news, and it was, you know, it got misquoted that cephalopods have alien DNA, right? And really what was said in the news story was that it's because of how long we've been separated evolutionarily from these animals, and the amount of things that we now have in common with them by convergent evolution, it's like the closest thing that we've come to so far to intelligent aliens being among us. They're not aliens. They did not arrive from an extraterrestrial object and get seeded into our oceans, but that got splashed all over the news as well. So if you hear people say, oh yes, and they're aliens, they've got alien DNA, you are now fully qualified to debunk that. That doesn't make them any less cool, right? And I know we had one on there about whether, octopuses and squid are smart. That's another good one. How many people think octopuses and squids are smart? That's kind of a trick question. Octopuses, so backing all the way up, it's extremely difficult for us to talk about what actually smart means in the animal kingdom. Okay, so when we say that they're intelligent, if we gave an octopus a human IQ test, and bear in mind how culturally explicit IQ tests are as well, so even, you know, different groups of humans, extremely different performing on different IQ tests, we really don't have any way to say that they are intelligent per se. They can do some very advanced things. They have memory. The more tests are done on them, the more advanced their capabilities appear to be, even beyond what we thought. Like cuttlefish recently passed the marshmallow test. I don't know if you know about the marshmallow test. This is where you give a 4-year-old one marshmallow, and you say, if you can wait 5 minutes, I'll give you 2 marshmallows. And that's, you know, that's a test of their ability to think into the future and sort of plan for that. And I think it's about a 50-50 success rate. So cuttlefish, which by the way we don't have in Aotearoa, I'm sorry to say, cuttlefish have the ability, after following a pattern of a preferred food item and a less preferred food item, to know that when the less preferred food item is offered, if they wait, a better food item will be offered. So they've devised a cuttlefish version of the marshmallow test, and the cuttlefish aced it. So and we just had online, thank goodness, had the triennial meeting of cephalopod researchers around the world. Some amazing talks there, and some other examples of things that, you know, people have devised to sort of see what else we can work out about how these animals' brains work. And every time it turns out that they are beyond where we predicted that they were going to be. So squid, not so much. I should say octopuses and cuttlefish do really well in these tests. Squid are very hard to test because they are extremely difficult to keep in captivity, right? A squid would never normally run into a vertical surface in the ocean in its entire life. And there's some other factors about them that make it basically nearly impossible for most institutions to keep them in captivity. So not a lot of chance to test their intelligence, but what we do know is that cuttlefish and octopuses live in this really complex seafloor associated environment where they have to be dealing with a lot of environmental factors all the time. And for squid, they live mostly in sort of a big featureless blue or black environment without all of that complexity. And that seems to have meant that they don't need such advanced processing abilities. On the other hand, they can color change as quickly as their brains can think it. Not quite to the same extent as octopuses, but the glass squids, for example, can go from completely transparent to brick red in a very short amount of time, including very fine control over different parts of their body. So sometimes the arms are red and the mantle is clear, or they have specific patterns. So I think I had squids are masters of camouflage on there as well. Well, we've discussed some of the ways that they are, but they also don't do the thing where they change their skin to look like seaweed sitting on a rock. That's an octopus and cuttlefish trick. Squids have a more limited range of colors, but then they also have some pretty cool things that they can do with what they've got in the meantime. Octopuses don't have light organs. Almost all octopuses don't have light organs. So squid have that going for them, and octopuses never have hooks. So, I'm still sticking with the squid. I think that was it for the stuff I was going to say. Did I miss any of the quiz answers? Did we talk about everything? Oh, the number of species. Anyone want to have a guess about the number of species we have in Aotearoa that we know of? Of course, this is an underestimate. Above 100? Ooh, nobody's willing to commit. Okay, we'll start low. Above 50, 72. We have 72. Yeah? More than 70? How many do you think? More than 80? 113. Keep going. 400. Oh, it would be a great day if we got to 400. Okay. We have a range of between 113 and 400. I'll tell you that about 15 years ago, we thought it was about 120. Right now, we're sitting at about 160. And there are parts of Aotearoa's exclusive economic zone that are not very well sampled yet. So there are certain to be more species than that, and we're still lagging quite far behind in giving names to the things that we know exist. We're getting to the point now, because it takes quite a long time to describe a species in the Western Linnaean system. We're getting to the point now where we're starting to do some pretty detailed feeding ecology and dietary work on some animals that don't have names yet.
Just tilt this back to thank you very much, everybody. Thank you very much to our speaker for tonight, Associate Professor Kat Bolstad, who is, of course, our favourite squidologist. She doesn't describe herself as that, I do, and I'm going to keep repeating it till it sticks.
Always.
So thank you very much, everyone, for coming at the first Café Scientifique of the year. Look forward to seeing you all again, same place, same time of the evening, in a month's time when we have Dan Hicaro from University of Auckland coming to talk to us about Matariki and what it all really means. So look forward to seeing you all then. If you aren't a member of the Auckland Museum Institute, you can come and talk to myself or to Nadine. Sorry, dropping Nadine in here is like, what, why are you witty at me? Come and talk to us. You can also just join online, flick us an email, all that kind of stuff. We look forward to seeing you all, and
I'll email out some video links.
yeah.
Don't forget if you want to receive the video links that somebody here has to have your email address.
I'm really good at reading minds, but I'm not that good. So yes, thank you very much. See you in a month. If you've got any other burning questions, Kat will probably hang around for about 2 minutes and 37 seconds if you want to ask some extra questions. Thank you very much. Happy to